Mobius Assessment, Lesson 8A, Homework Question number 10. Graph the exponential function f of x equals 3/2 times 3/4 raised to the x minus 1. Use the following to help you plot the function. When x equals 1, f of x equals, the y-intercept of a function is, the horizontal asymptote of the exponential function is at y equals, and then graphing. So the first thing I want to do is find when x equals 1. Now the reason they picked that is because it's a really nice, easy number to find for us. So I have my document here, and I have all of the information given to us from the textbook. Really quickly, just want to kind of explain a little bit of this. It tells us the y-intercept at 0. It gives us the y-intercept of a plus c. Now we can think of that, or we could just plug in 0 for x and solve, which is what I would do because that's what we do with all graphs to find the y-intercept. You just plug 0 in for x and you see what comes out. If you want to memorize the a plus c so that you don't have to work it out, that's totally fine and up to you. However, I'm just going to throw in the 0 and work it out. The next one is when the horizontal asymptote, which is y equals c. Now this one you can also kind of figure out, or you can memorize, which in this case I think it'd be faster to memorize because you just have to know that it's c. And this is just saying that no matter what number we put into an exponent, we can never actually get it down to 0. And I have an experiment that I could show you with that really quickly here, just for fun. And just briefly here, decreasing and increasing, it's decreasing when b is a fraction. It's really just that it's a fraction, and if b is bigger than 1, then it's increasing. If it is 1, then it's flat, right? So if we come into here, just for the sake of experimenting, I know it's not going through your problem right now, but it might help you understand what it means that the horizontal asymptote is y equals c. It's just wherever that line can never go to 0. So I'm going to show you why. If we take an exponent, base 2, that means 2 being raised to an exponent, I have positive numbers, I have 0, and I have negative numbers. And I'm just going to type in 2, shift 6 for the caret, raised to the 5, just to show you these are what we'll get. That's just 2 times 2 times 2 times 2 times 2, and then so on and so forth. When we get down to 0, anything raised to the power of 0 is just 1. And then these ones, the negatives, it actually becomes a fraction. And so it just, as I explained earlier in a video, if I have something being raised to a negative, it just means it needs to go to the opposite side of the fraction bar. So if I have a negative on the top, so 2 being raised to the negative 1, it just needs to be dropped down, and then it becomes a positive 1 because it's on the right side of the fraction bar. And then this one, so this is 1/2, this is 1/4. That just means the 2 came down on the bottom of the fraction, so it's in the denominator, and it's being squared, and it's positive now since it's on the bottom. So 2 squared is 4, and it's 1/4. Either way, you can see though that it just becomes smaller and smaller fractions. It actually can't ever get to 0. It just makes it just another 2 on the bottom. And so that's just showing that we can't get to a 0. Now here we have, okay, so this is base 2, so this is larger than 1. So this is another thing that we can show over here. If we have a fraction in the base, so is 1/2, it actually shows that it's decreasing instead of increasing. So because these negatives get from the smaller to the larger, I'm getting bigger, this is going to go in reverse. So we're going to do equals, parentheses, so that the 1/3 stays together. You know what? We'll do 1/3. And then raise this to the exponent, and then fill it in, and you can see that it actually gets bigger this direction. So if we were to look at, I'm going to go find that picture. Here it is in our textbook. So if we have, this was our decreasing one, that's the fraction, and you could see that as the x got smaller, the y actually got bigger. And if we do it over here, when the x got bigger, the y also got bigger, and that was the increasing portion. which is where all of these numbers look like when we're actually graphing it. So that's just something to kind of explain what the textbook was going through. All right, so now let's actually get to calculating the problem here. And so the first thing we want to do is find when x equals 1. So it's just kind of nice. We can use Excel, we can do it by hand. I'm going to go ahead and do it by hand first so that you feel that you have the confidence to go ahead and do this by hand on your own as well if you wanted to. So we're going to copy this, paste it here, and substitute in 1. 4/3 being raised to the 1 is just 4/3. It doesn't change anything, it just says that it has one of them. So to evaluate that, calculate it, it's just 4/3. 4/3 times by 3/2. I can multiply numerator to numerator and denominator to denominator, or I can simplify beforehand. Here, if I multiplied numerator to numerator, I would have 12, and denominator times denominator is 6. 12 divided by 6 is 2. Or I can simplify beforehand and do 3 because I have, I'm going to come up here so that you can see a little bit better. 3 is in the numerator and the denominator, so I like to think of them as crossing each other out when really it's just dividing. 3 divided by 3 is 1, so they're just gone because I get a 1. And 4 divided by 2, I have a 4 on the top and the 2 on the bottom. 4 divided by 2 is 2, so I have a 2 left on the top. And so the whole answer is just 2. Either way you like to think about it, that is 2. So we're going to push paste here. 12 divided by 6, or he's simplifying beforehand. Either way, we get 2. 2 minus 1 equals 1. And so we can put that here, and that's our first point that we can graph on our coordinate plane down here, 1, 1. So we go to the origin, and we go over 1 in the x direction, and then up 1 in the y direction. And I'm going to try and get that pretty close. I can't get it really exact. You'll notice I hover over that it's close enough though. The y-intercept of the function, like I said before, you can memorize a plus c, or you can just put in a 0 for x and solve. When I put a 0 in for x, anything raised to the 0 power is 1. So this whole thing becomes 1, and that's why we do a plus c. Because c in this case is negative, we're actually going to do 3/2 minus 1. I'm actually going to copy and paste this so that we can see this in action here. Oops. My 0, or my x is a 0. Anything raised to the 0 power becomes 1. And oops, I should put 0 here. That's what we're evaluating at. Copy, paste. This is just a 1, and 1 times 3/2 is just 3/2. And so that's why I don't memorize that a plus c, because I know that I can always go back to just plugging in 0. 3/2 is actually 1 and 1/2. Subtract 1 just leaves me 1/2. Now I can do that in my head pretty quickly, but I think that it would be really nice to see how to combine fractions if that's something that you're not very comfortable with. If I have 3/2 and I want to subtract the 1, I need to have a common denominator. Since this denominator is a 2, and I can make 1 into a fraction by just putting it over a 1, then I take that denominator, the 2, and multiply it to the numerator and denominator of the number that I want to subtract so that they have the common denominator. So I end up with 3/2 minus, actually 2/2. And the reason I can do that is 2 divided by 2 is 1, and I haven't changed this value at all. It's still 1, right? 2 divided by 2 is 1. It's still equivalent. So now I take the numerator, 3 minus 2, which is 1, and the denominator you don't subtract when you're subtracting fractions. It tells you how many pieces you've cut up something into, and so it stays the same when you're subtracting. So that's where the 1/2 is. And so that is our y-intercept, and I'm going to type in 1/2, and hopefully, and you will see if it's okay to type in the fraction versus the decimal. If you're more comfortable with decimals, I think it'll also accept that as well. The next one is to find the horizontal asymptote, which was given to us in the book as y equals c. And this is one thing that I probably would memorize. If not, you can always think of it as where would this go, like it can't go to 0. So how would I do that is taking this exact number, -1, and then that would make this exponential part of the equation equaling 0, which is where it can't go because it will never go there. So that's one way you can think of it. But in this case, it is much faster just to memorize. You take the last number, -1, and then we're done. So now all I have to do is go put all of these in here as I graph it. The y-intercept of the function is 1/2. We're going to come down here. This is the y-intercept, or the y-axis. It's the tall one, like we discussed in the other videos. There we go. And then we need to tell the horizontal asymptote of y equals -1. So we're going to come down here. This is -1. And it's a horizontal asymptote. So we go down -1 in the y direction, but it'll draw us a line here. There we go, it's -1. And there's our graph. So we're going to graph the point, a y-intercept, and then we're going to give it the horizontal asymptote. And we can check this on the how did I do. Look for our green check marks, and it looks great. Everything looks great. If you have questions, feel free to email me, and I hope this helps.